Hello, everyone, and welcome to this TDE Workload Generator 6.0 webinar. Henry will be today's speaker. This session is being recorded and will be made available online. A follow-up email will be sent from training@virtualinstruments.com, sharing the link and notifying you of the availability of this recording. I've muted everybody except the presenter to eliminate any potential background noise. Please hold your questions until the end, at which time I will be unmuting people and facilitating questions. If you have not done so already, please enter your audio pin so that I'm able to unmute you when the time comes. With that said, I'll turn it over to Henry.
All right, thank you very much, Ken. Hello, everyone. Good morning, good afternoon, and good evening from different parts of the world. All right, so today we'll be focusing on the TDE/Workload Generator 6.0 release product update. Now, for those of you who may be interested in our other product update, the WorkloadWisdom, which used to be called Load Dynamics Enterprise, we did that two days ago on Tuesday morning. So in case you missed that and you are interested in that, then please please look for the emails that we send out, where it includes information about the recording and how you can access it at any time at your convenience, so you can go over some of the very important product updates that we shared as well for the other product, WorkloadWisdom. So today we are going to focus on TDE and Workload Generator 6.0. Now, before we get right into the 6.0 update, I just want to give one slide to share with everyone some of the major items that came out last year. So in case you missed some of these items, it would be good for you to just reach out to us and ask more, ask for some details or upgrade to some of the either the latest version or the version just before it, just so you can catch all the things in 2017 that you may be interested in. So in 2017 was the year where we really focused on a lot of delivering higher speed Ethernet and fiber channel interfaces. We introduced workload generators for 25 gig Ethernet, 40 gig Ethernet, and 32 gig fiber channel. All of them are carry the same capabilities as their predecessors, which and what I mean by that is their earlier speeds, such as 10 gig Ethernet, 16 gig fiber channel. So same sense of functionality, but faster. So that's always good. On the protocol side, we also expanded a lot of features for these various storage protocols that we already support in the product. For NFS, we added NLM and NSM support. For SMB, we significantly improved the credit configuration as well as dynamic credit handling capabilities. For our iSCSI and fiber channel on the block side, we added iSCSI discovery as well as several block related enhancements. And on HTTP object, we added some capabilities to allow our simulated clients to retry whenever the server sends a 503, as well as some other user-defined response codes. We added a brand new capability called a Diagnostics Suite, and that we're actually going to get into a little bit more details in upcoming slides. So the quick takeaway here is that so far it has been a very, very exciting feature. Every customer that I've shared this with have found it to be very interesting and very useful. So we'll get into more details on that in a few slides. And on the automation side, we also added REST API to the workload generator so that you can begin to manage your workload generator assets in your lab, as well as kick off some tests that you already have, all using REST API, in addition to the Perl Python APIs that you already have for many years. And at the same time, we also added many different user interface and user experience improvements. So 2017 was a pretty impressive year for our products, and I hope that if any of those items catch your attention, certainly please feel free to reach out to us and get more information about it, especially some of the higher speed workload generators. Certainly, since we introduced them, we have seen an uptick in our customers also upgrading their own test labs from the de facto 10 gig Ethernet or 16 gig fiber channel to higher speeds. All right, so that was the one slide 2017 highlight. So now let's get into 6.0. 6.0 is also a very packed release. Quite a bit of new product features, as well as usability improvements, as well as protocol expansions for iSCSI, SMB, NFS, and Object. And there's more to what I'm going to share today, and there will be in the release notes. Now, in the other thing I would like to mention for today's webinar, you see that there's a little asterisk next to the 6.0, is that there have been a few new features that were introduced in the 5.8 service packs as well. So of course, when we were doing the 5.8 product update, these service packs have not happened yet at the time. So some of the features that were introduced in the 5.8 service pack were never really publicly introduced. So in today's session, there are about, I think, just 2 features or so that were included in the 5.8 service pack that I will go over as well. All right, very first thing, let's talk about a brand new feature that we are working on called RageTraceReplay. One thing I want to know and want to point your attention to is that it is an early availability release. We have not formally declared a GA yet because at the moment in 6.0, it is an experimental feature, and it's a feature that is very innovative and provides an entirely brand new use case. However, it's also a very complicated feature, and initially for users who may want to use it, you have to work directly with us first, where we have to do some manual work for you and with you in order for you to utilize this feature. So at the moment, this feature is included in 6.0. This feature is found inside the experimental folders, so it's not available by default. You have to go to options, enable some preference, enable some advanced options, enable to surface this feature. So that's the first expectation I'd like to set. So what does ReplayTraceReplay do? What does it do? So what it does is that it will allow you to take some sort of, let's say if your array produces a very granular command by command trace, essentially record of every single command that your array sees at every whatever timing interval that you capture. But in most cases, in order for this feature to be useful, you have to capture every single command and the timestamp associated with with each of those commands. So at the end, you have some sort of trace file that gets produced, and this trace file contains the actual command sequence that's chronologically observed by your storage array. So at timestamp 1, you have this particular command hitting this particular LUN, and with this particular block size, and at the very next timestamp, which could be just a few milliseconds later, you have this other command hitting this particular LUN at this particular block size, and so on. So you have this trace file essentially that we can now parse and ingest into our workload generator. And this is once the file is parsed in a format that our workload generator understands, then this file is considered it's called a replay data, whereas the originating source of the data, essentially the data that your storage array captures, we call that the trace data. So essentially, to put all those terminologies together, we take that trace data, parse it, and convert it into a replay data, and the replay data is something that our workload generator understands. And then it will play back that same exact sequence of commands, timestamp by timestamp, command by command, at millisecond granularity, essentially. So here's some of the key, your storage array your storage array's trace data, if you do provide that, can contain a lot of information, far more than what we really need, right? So what we parse out of it, the minimum set that we need, obviously timestamp, the IO command, so this, think of it as opcode, the target, the LUN, the size, and the block size, and the LBA. So that's really the core set of information that we need to create this replay data. And then during the replay, here are some options that you can play with. You can do a partial replay, you can do a full replay, you can replay once or have it on repeat. You can speed up the replay or slow down the replay. What it does is either expands the time gap between each command, or it condenses the time gap between each command, just to help you better understand, okay, if your storage array gets the same exact workload in production in your customer's environment, but for whatever reason or somehow that these commands are happening a lot faster, or what is that? How does that impact performance? So the typical use case for this is to recreate short-lived transient workload behaviors. So for those of you who are familiar with the workload data importer feature or the workload production to lab automation feature that we have in WorkloadWisdom, it's a different use case. And these two are complementary. I want to make that very clear, because on the surface, it sounds like these two are almost competing features, or they're completely they're completely alternatives, or the X versus Y, or A versus B. No, these are really complementary. The WorkloadWisdom production to lab automation is for recreating these workload general statistical workload model of your production workload environment. So it doesn't really it makes sure that it maintains the statistical distribution of different commands and block sizes and the load over time. What it doesn't do is to ensure that command A is followed by command B is followed by command C in millisecond increments as observed in the production environment, right? So in the former, it's generally used to create workload models that span over periods of hours, days, weeks, or even longer. RageTraceReplay is really designed for a very specific use case, which is to recreate short-lived transient workload behaviors command by command. So as you can see, these two are really complementary. They serve different purposes, and both are different solutions that we're going to support as we go forward. So to provide a bit more details into how we designed this feature and why we designed it to work with potentially any different array data out there that your array may produce from version to version or from product line to product line. So we designed it to be very versatile, and it is a generic framework that we can use to replay array data from potentially any source. Initially, we're going to focus on fiber channel and iSCSI because certainly when it comes to NAS and object, it can get a lot more complicated in reads and writes, as we all know. So the procedure of using this solution, step one, you will extract the trace data from your array. And a lot of times you may either want to do this in the lab environment, or your customer may ask you to do this or you may ask for this information, or you may ask your customer if you can get this information from your array deployed in their environment for troubleshooting purposes or something similar. So that's step one, you extract that trace data. Now, step two is that we will convert that trace data into the replay data, because we work off of replay data, and the trace data could be completely different from one product to another. And then step three is to create a TD test with this replay data and this is the procedure for version 6.0. After 6.0, we'll try to simplify some of the steps here, especially step 2 and step 3. But in 6.0, these are 3 distinct steps. And as mentioned, this is an early availability release, and it is in experimental mode. So it does require you to work with us, especially for step 2 and step 3. Step 1 is certainly completely on you, but step 2 and step 3, this is where we work together with you. And let's talk about some of the design specifications. So the precision here that we can guarantee is 10 microseconds between command to command. And the only exception to this is the write operations. The write operations here will vary, depends on the payload size and the payload content as well as the size of the payload. And this is because we have to take CPU cycles to create that data pattern first before we send it out. So there is that variation for write section, vary between 50 to 250 microseconds. So just anywhere from 512 bytes to 64K. So smaller, less impact, larger payload, more complex content, takes longer to prepare. The maximum replay data that we can deal with is the 1 gigabyte in file size, and what that really translates to is potentially hours of actual command records, because the replay data file itself is pretty slimmed down. Think of it as a simple CSV with just 5 or 6 columns. So you can imagine 1 gigabyte file size. It actually has a lot of commands and details that can be captured in this replay data. And right now, in 6.0 will support up to 30 unique commands and opcodes that are observed in the replay data. it's not really our system limit is that. This is an experimental feature. We don't know what's a reasonable limit, so we can go far more. But I think yes, we think that we'll start with 30 and see how it goes. If we need to, if that's sufficient, okay, we'll leave it at that. If we customer found that, if we find that no, we really need 100 at least, then that shouldn't be a problem either. We're also adding, working on some enhancements where it will allow the synchronization between ports. So this is useful if you have trace data coming from an MPIO environment or coming across from multiple ports. So during replays, it's important that these different commands from different paths are getting replayed with the same at the same relative timestamp. Relative order. So we'll make sure we'll do that as well through the inter-port synchronization feature. The replay options we talked about earlier as well, and the minimum data set we needed also talks about that as well earlier as well. So here's just one specific example. It could look like many different things. So whatever trace data it may be, you have a variety of different information, right? It doesn't matter whatever it is. Working with the VI staff will convert that into a uniform replay data. And then that replay data gets imported into a TDE project. And the way we actually design this to be generic is that we'll allow you to tell us what opcode that's observed in the replay file should be recreated using one of the commands we support. Now, by default, you want to use the same exact opcode, right? If it's, you see that, okay, it's a 28, okay, you do a re10. If it's 8 alpha, you do a write 16. You do a 0, you do a test unit ready, right? So, but however, if you understand, and most of you on this call are familiar with how TDE works, there's nothing stopping you from saying, you know what, anytime I observe a 28 opcode in the replay data, I don't want to do a re10, I want to do a re12 instead, or I want to completely do something different like a BAI command, right? So there's a lot of customization and advanced capabilities that you now begin to have by harnessing the power of the replay RageTraceReplay feature with the existing capabilities that TDE already offers. And you can create, you can create threads, you can create async behaviors, you can create loops, just quite a lot of things that you could do here. Introduce deduplicable data content and so on. So that is, in a nutshell, the general design concept of a RageTraceReplay. And what I just explained now explains really the key takeaway is that you could use this feature to recreate the workload command by command, if you like, or you can really begin to customize and change the command the replay data that was created, and start to customize it and see, well, what if all the re10s became a re16, right, and things like that, or what if all the writes became reads for whatever reason, if you want to do that. All right, so the RageTraceReplay, if that's something that you're interested in, I would just suggest you reaching out to us, because while conceptually it is pretty simple to understand, it does take a lot of work to actually get it right and make it work. And that's why we're not calling it GA yet. It's really just in the experimental mode. And this is something that we'll be improving later. All right, so let's move on to a few other topics here. The Diagnostics Suite, this is something I talked about in the introduction slide. That's a feature that's been very successful with customers. So I'll talk about what this is. And within this Diagnostic Suite, there are really two components. There's a real-time alert system, and then there's a summary file viewer. The real-time alert system is something that was introduced in the 5.8 release, and it's something that we continue to add on every release after that. And I'll explain why we do that. The summary file viewer is a post-test viewer. So these two are different. They serve different purposes, but both of them give additional abilities to the user to troubleshoot, to understand, to diagnose issues that were encountered throughout a test run. Let's begin by talking about real-time alert system. And some of you, have already seen this. Some of you have already upgraded to 6.0 and already started using it. So, for those of you that have done that, this is just a quick review. Now, this real-time alert system was designed with one purpose, and that one purpose is to help users more quickly narrow down the root cause or the source of an error, a source of an error that was encountered during the test run. Before real-time alert system was introduced, users identify errors by, at least when using TDE, users identify errors by looking at the real-time charts that says, oh, I have so many errors that were encountered throughout the test run, or I've encountered error with the get attribute as well as set attribute. What users did not have is, again, 10% of all the read operations were failed for some reason. That's what users have before 5.8. Now, what users did not get before, with that is, well, exactly which client, between which client IP address and which file server was this server observed from? Exactly which file out of these millions of files triggered this particular read error? Right? Those are the things that we did not provide before, and users wanted to have that. So that was the purpose of the real-time alert system, is to not only let users know that an error has occurred with a particular command, but tell you which endpoint, which file, and which offset, and so on. Now, there are different modules that were put together into place for this real-time alert system, and it's broken down to 3 modules. There's a TCP/IP module, there's a data verification module, and there's a protocol module. TCP/IP module goes through essentially, this is the generic framework. You think about the TCP/IP OSI stack model. Any IP-based storage protocol will share this TCP/IP module, whether it's iSCSI or Object or NFS or SMB. And within this TCP/IP module, it provides information about the timestamp an error was observed, the source MAC address, destination MAC address, source IP address, destination IP address, source TCP port, destination TCP port, the TDE scenario name where this error was triggered, and also the specific action index. So this is, if you look at a TDE scenario, it'll tell you this is the 13th command in this scenario, or this is the 21st command, in the TDE scenario. So that's the type of granularity the TCP/IP module gets into. The data verification module is pretty self-explanatory, and this is really not too different from the existing data verification chart that we already have in the product for many years. Now, the protocol module, this is the part where we need to add support, dedicated support for release by release. In 5.8, we added support. We started the support with HTTP and Object, and that was really because we were working on, when we decided to come up with this concept, we were working with a specific customer on this particular feature, and to that specific customer, thank you for working with us on that. So that's why we started out with Object. But certainly, things for the popular protocols like iSCSI, SMB, NFS, Fiber Channel, those are certainly under high demand as well. So in 6.0, which we're going to go over in more detail today, we added support for iSCSI and SMB. And then in upcoming releases, we'll be working on NFS, Fiber Channel, Kerberos, and some of the other remaining protocols that we have support for. Now, a lot of times we focus on the real-time aspect of this because these alerts do come up in real time while the test is running. However, these are also available at the end of the test. So don't worry about, don't be concerned that this information is only available in real time. It's not. It's just that it's available real time, which is the nice part, but it's also available post-test. HTTP Object, we're not going to go over too much here because we already talked about it in an earlier release when we did the 5.8 product update. So today we want to focus a bit more on the iSCSI and the SMB pieces. So these are already available in the 6.0 release. And for the SMB side, and you can see this, an example of a screenshot here. It gets into pretty detail here. So on the SMB module, certainly want to provide some of these SMB-specific error diagnosis, such as, the connection piece is pretty generic in concept between any protocol. So this is the SMB client and the specific SMB file server, but also get into more details, such as the SMB share, where the information was found. As you can see in the screenshot here, you can see a share name as well as a share ID, and also the specific file that's where the error was encountered. So not only do we get the error code specific to SMB protocols, but also get a specific file name and some of the file IDs, and also get into even more details as that exact, in this particular case, right, exactly how far into the read operation, it's the block offset essentially where an error was encountered. So what this tells us that, well, in this case, right, with this particular file called file25.test, we didn't encounter any errors for the first 21st blocks of the read operation, but first 20th, starting with the 21st block of this read IO into this specific file, we encountered an error. So that gives the user some very detailed information to, okay, I need to focus in on this particular share, on this particular file. How was this file stored? Why did an error occur in the second half of the file, but not the first half, right? So a lot of detailed information that are provided here, and similar in concept for iSCSI as well. On the screenshot on the right-hand side here, there is the screenshot for the iSCSI module where you can see it gets into very, very detailed information, the specific run, some of the specific the header information that were tracked in the SCSI PDU, and then also the exact opcode, there are all the flags that were associated with iSCSI PDU. So just a lot of information that are shared here. So for 6.0, if you're doing any testing with SMB and iSCSI, certainly highly recommend you to upgrade to 6.0 and actually, really take advantage of some of these new features that we're adding for a real-time alert system. Moving on to the related topic of summary file viewer. So summary files, some of you may have already dealt with this before. Usually our engineering team, our support team, may ask for this in the event you call us and you're really trying to figure out what happened in some cases. So summary files is something that we have always provided and produced at the end of every single test on every single port. We've been doing this for years. Just that most of the times you don't have to deal with this. You don't have to use it. And in the past, when we do request it, usually only our engineering team can extract and can understand the summary file, because there was no viewer available for it. It was a binary file, and we really just, we use our own internal tools to create visualizations for these summary files. So in 6.0, we made this generally available to all users. And this will come in the form of a separate Windows installation. It's free of charge. There is no additional license needed. When you upgrade to 6.0, the files you download from our cloud drive will include both the TD installation as well as the summary file installation. So this will be a separate program within the on your Windows VM or machine. Now, the neat thing about a summary file viewer is that it records every single step throughout the entire test run at half-second intervals. So this is going to be the most complete, most granular set of statistics that you're going to get from your test run. And this is, whether you're running a 1-minute test or a 7-day test or longer, these stats will be maintained at half-second granularity intervals. So it's going to be the richest set of data, statistics that you're going to get about your test run. Now, the one key thing to note and one key caveat with the summary file viewer is that if you think you want it, right, you have to enable it when you start the test, and then you have to download it at the very end of the test run. Because the moment you start the next test, the summary file that was saved on the workload generator port is deleted, and the new summary file will be created for the next test run. Right? So it's something to keep in mind. So in most cases, you're not going to need it. And really, the key takeaway is that if you haven't had to use this in the past 3-4 years, you don't need to worry about this. If you feel like if you happen to run into some really difficult to trace issues or performance issues, and you want to find out exactly at what timestamp with which command trigger some of these performance peaks or valleys, and you think you want that type of information really drill down on a per second level and a per command level, then you do want to enable that summary file at the beginning of that test, and then give it some time to download that at the end of that test run. And once you download it, you have it on your computer, and then you don't have to worry about it again when you start the next test run. Okay, let's get into some of the protocol-specific enhancements that we added. For NFS v4, we added the support for NFS for the X referrals, and what this does is that if you have an environment where you're providing a multi-server namespace, and SMB has something similar as well, pretty much any modern file system solution has something similar. It essentially distributed namespace or distributed file system deployment. So if you support NFS v4.1, 4.x referrals as defined by the standards, then you will be able to now test this with our product. And what we did was that we basically added capabilities to our simulated client to respond dynamically if your server responds with an NFS4 error moved when we send out a lookup request. But in this case, in this particular response, we'll note our clients dynamically, automatically respond with an FS locations request, and then your server, according to standards, will provide a list of FS locations within your response. And then what we'll do is that in our next action, we'll now connect to this one of the file system servers that your service has told us to reconnect to. So conceptually, it's pretty straightforward. That's really it. It does require a little bit of modification to your NFS v4.x test if you already have one and you want to extend that to take advantage or leverage referrals. So it does require the use a bit more customization to your TD test. And if you need assistance with that, then we also have a sample test that we can share with you. Another enhancement that we added for NFS v4 is add the ability to allow you to automatically create unique client IDs on a per connection basis. So before this, we've always had, which is a default option, is that we'll create a unique client ID per scenario. So the difference between these two is that if there is any reconnects, any TCP connections or any additional TCP connections that needs to be spun up within the same scenario, then if you have set it to unique person scenario, oops, looks like my PowerPoint crashed again. So give me a moment to bring that back up. Now, while this is loading, I'll continue on with the description. Is that within the same scenario, if it's a new connection that came up, well, before 6.0, the client ID will remain the same. So with 6.0, now you have the additional ability to have a unique client ID for each new TCP connection, even if that connection spun up within the same scenario. So the way that we concatenate the unique client ID in this case is it starts with SWT with the client IP address, server IP address, scenario counter. So all that so far was the same before 6.0. So what's new in 6.0 was the connection index that gets added at the very end. So that allows us to keep that unique client ID. We want to do something different on the iSCSI side. We expanded some of the data transfer control capabilities for iSCSI, and what it does is that it will allow you, it will now give you the control over how you want our initiators to essentially transfer that data. Now, according to the iSCSI specifications, essentially there are two filters that we have now made available to you as a user. That essentially there's an initial registry transfer and then there's an immediate data. These two parameters work together between the initiator to target to really set up and define how these data transfers are going to happen between whenever the target is ready to receive data. So between these two flags, and these are two binary flags. All right. by definition. The initial R2T, ready to transfer, and then immediate data. So depending on how it's set, it dictates whether unsolicited transfer is allowed, and if allowed, how many of those unsolicited transfers shall be transmitted from the initiator to the target. So in this case, and again, this is all just by standard. If you want to get more information, just look up the iSCSI RFC, and they'll explain some of these different behaviors. So essentially, as a user, you can set this to 4 different behaviors. When you set both flags to no, then what happens? What you're saying is that one unsolicited data out will be allowed before the first R2T is received by the initiator. If you set the initial R2T to no and the immediate data to yes, then it basically gives them flexibility that either one unsolicited data out or one immediate transfer are allowed before the first R2T, and so on. If you set the initial R2T to yes and then immediate data to no, that means that no unsolicited data transfer is ever allowed. Transfers are only allowed when the target says R2T ready to transfer, and so on. With the fourth remaining possibility, which if you set both flags to yes, and in this case, you will allow one unsolicited immediate transfer before the first RTT. So all this is completely standard space. So this feature gives you some additional capability and customization in how you create that iSCSI test and how data, whether unsolicited or unsolicited data, is transferred from initiator to target. On the HTTP object side, one of the requests we also received was to allow for the verification of server certificates. So anytime you're doing HTTPS testing or any object, whether it's Amazon S3 or OpenStack Swift, and you want to run that over HTTPS, you now have this added ability to upload a server certificate into TDE and then set the option that says I need this. I need to verify this server certificate. Also has the ability to also upload a client certificate if requested by the server to verify that as well. So the way the usage works is pretty simple. Essentially, as you can see in the screenshot here, there isn't a whole lot to set, right? If you have when you do have that server certificate, providing to upload to TDE, and then set verify server certificate to true. And what happens is that during the test run, when we do receive that server certificate, we're going to validate what was received from the server against this server certificate that you upload into TDE, and make sure that it matches and it's validated. And if it is, then it will allow the test to proceed. So pretty straightforward. However, could be essentially almost a showstopper in some cases if you need to verify, if you have a test of use case that requires that validation. Okay, I really need to check with my IT to see what's going on with PowerPoint today. It just happened to crash again, so let me bring that up. All right, good news is that we're reaching almost the end. Another enhancement that we added for object testing is the lifecycle policy for Amazon S3. So if you're doing S3 testing, then one of the new features that you'll be able to use, starting with 6.0, is the lifecycle APIs that are defined in the Amazon S3 specification. So essentially, what the lifecycle policies do is it allows the S3 object store to apply policies to objects and buckets that are created to automatically age them out. And as you get aged out automatically, they're also moved into different storage tiers to some of the colder storage tier storage, such as Glacier, for example. So it's a mechanism that allows you to really maximize or optimize, or allow enterprise your customers to maximize and optimize the different tiers of storage at the appropriate cost. So if that's a use case that you support and that's a use case that you want to test, then that's available for S3. So as you can see in the screenshots here, when you you actually create a bucket, you can start to also put in some of these bucket life cycles as well. You can define the age, you can define the names of policies, you can define which storage class the objects within the bucket goes into after a certain number of days, and you can apply multiple rules per bucket lifecycle. So a pretty flexible capability that is introduced in 6.0 that you can start using right away as soon as you upgrade to 6.0. And all that is based on the Amazon S3 specifications. All right, now for the remaining couple of slides, these are sort of usability improvements that are added to TDE. So regardless of what protocol you use, these usability improvements apply to all. So these are some of the things that really just apply universally, regardless of what technologies you test with, whether it's NFS or iSCSI or Fiber Channel or Object. Alias is something that is very useful for humans to identify, to have a human readable name and associate that with something that's difficult to keep track of, like a complicated ID and so on. Handles are something that are pretty powerful in TDE, and most of you use them either directly or indirectly. The trouble with that before 6.0 is that when you have, let's say, multiple handles from the same action, it became difficult to keep track of which handle was the first create file command for, and then which file handle was the second create file command was for. Right, and that applies to iSCSI and Fiber Channel as well. If you're doing the read capacity multiple times across different sets of LUNs, well, it became difficult to keep track of which read capacity was for which sets of LUNs. So we added an alias capability. So anywhere where the action produces handle, you will now have the ability to enter a user-defined alias, and that user-defined alias will automatically show up in the list of scenarios as well. So as you can imagine, in this particular, if you have a scenario with multiple actions that have the same name and that produce but they're working off of different file handles or LUN handles and so on, it'll be very easy now in 6.0 to keep track of exactly which action was for which set of file handles. Another improvement we made to the usability of TDE is the is to essentially better manage a set of actions that you may have in TDE where there's a begin to it and an end to it. So just like many powerful program languages where you have your if-else loops or a for-else, for loops and while loops and things like that, there's a begin and an end to it, right? So very similar in TDE as well. Some of you have already used threads, you've used async, you've used loops, you use if-else and more. So all these different action sets have a begin and an end to it. Now, in a complicated scenario, right, your scenario can be very long, and a lot of things that happen inside that bracket that happen between the begin and the end to it. You don't always need to see it, right? You can, in some cases, you might even want to collapse them if everything's going well. You don't want to deal with it. So that's precisely what we're adding in 6.0 is to give you the ability, if you see a little upside down caret here, you can click on it to expand or collapse all these bracketed action sets. So you can essentially take, say everything under this particular highlighted if loop here, and collapse everything, and that you don't need to see it until you really want to get into it, expand on it. And the other nice thing is that all the action indexes they're not going to change whether they're collapsed or expanded. And that's nice because there are some actions in TDE where it references another action by the line item. So you don't want to change that just because you're collapsing everything here. So that's the nice thing about it is that all the action index and numbers, they don't change. And also earlier we went over this real-time alerts feature, right? Where it tells you the exact error, the exact number of action where the error was encountered. There's an action index that says, well, it's a 12th action where this error, where this error was triggered. So you don't want to lose that information either. Right? So you can, the key takeaway here is that this is purely a UI usability improvement. It doesn't change any underlying action or underlying TDE project. So feel free to expand and collapse, as much as you want. Now, the other enhancement that we added after 6.0 was also we added indents. So now when you have bracketed actions, just like many programming languages, softwares, everything under these bracketed actions, they will be indented a tab over. So it makes it even easier to identify whether a command is at the top level or within some nested commands. All right, so that was essentially a summary of the 6.0 product update. The release notes will have a bit more information as well. And just to give one high-level slide on some of the things that we're currently working on as we speak, that would be that we plan to make available in the next product release. So one of the main focus we want to focus on now, since the TDE product is already pretty powerful across many of these storage protocols and simulations. One of the feedback we consistently hear from you and others is that, when I want to bring on a new team member, it was very difficult for them to come up to speed quickly, and it's difficult for them to get results quickly. It's a very challenging and difficult tool to use. Now, I also want to set some expectation, right? I mean, TDE is designed to be a very powerful and highly customizable tool. So, it's not ever going to become an Airbnb app where you can just, anyone can figure it out within 30 seconds, right? It is still a very technical tool. However, we are going to take a major focus in the next release to create a lot of improved sample content that new users can really rely on and begin using and get results much more quickly than before. Right now, we do have sample tests in the TDE product, and some of you do use it. But as you may have observed, some of those sample tests, even that aren't really intuitive. They're not really designed to train new users, enable new users. So that's the major focus we're taking on into the next release. Is anytime you want to onboard new users that within your team, which you can really trust, you can really recommend them to start with a sample test. And we're going to do that for both TDE as well as the automation API as well. So some of you who are using our APIs have also struggled at the beginning, where you really needed our help to get a simple test going. So we're trying to solve that problem first in 6.2. Earlier, we talked about the real-time alert system, and we're talking about we'll continue to add support for it and expand on it. So one of the major things we're adding in 6.2 is API support. Some of you have directly requested it to us after we introduced the feature to you. You said, well, you mentioned to us that, well, UI is great for our UI TDE users. They will use that, but hey, I'm an API user, right? I need this information in API. So that's going to be added in 6.2. And as far as protocol modules, we're going to be adding fiber channels support and kernel support. In the summary file viewer we talked about, right now in 6.0 it's considered beta because there are a couple of corner cases and where there's some issues that we haven't fully resolved yet. So we want to make sure those corner cases are resolved first before we feel comfortable calling that a GA feature. The RageTraceReplay feature that we talked about at the beginning of this session is something that we're going to, as mentioned, it's a brand new experimental feature. We're just getting started with it, so we'll continue to work on improving that. For NFS improvements, we're going to add NFS v3 threading. We're also going to improve some of the low-profile behaviors of the NFS protocol. So some of you who have requested NFS v3 threading for a long time, you can expect that in 6.2. And some of you who want it, who have encountered some unintuitive behaviors when it comes to NFS low profiles, you can expect those to be better in the 6.2 as well. For iSCSI discovery, which is introduced in 6.0, no, sorry, 5.8 service, actually, I believe. We're going to add VLAN support for it in the next release. And also the server certificate verification, which we introduced in 6.0, we're going to continue to expand on that, improve that as well, add some additional capabilities there. So in short, that is the product update for 6.0. as well as a quick high-level look at some of the things that we're working on in this upcoming release. So now, Ken, if you want to help me with, I don't know if there are some questions in the chat, or if anyone wants to raise their hands and ask questions, we can do that right now.
Thank you, Henry. If anyone has any questions, if you would like to type them into the chat window or raise your hand, I can unmute you. I'm not seeing any questions so far. Last call for questions. I don't see any questions. I think your presentation has successfully answered everything anyone would need to know.
All right, well, thank you all so much for joining this session, taking time out of your day. One thing I always appreciate is, those of you, just keep giving us feedback, keep using our products, keep upgrading to the latest versions. As a product manager, that's really the best validation I can get that we're doing things right. And also, we're also here to heard you loud and clear many times when you raise support tickets, we encounter issues. Those are things that we need to acknowledge, we need to work on and improve. So really appreciate feedback in all forms. So thank you so much again, and have a great day, great evening, wherever you are. Take care. Bye.
Thank you, everyone.